Hello, this is Moresh, and today we are going to continue on our series of Arduino tutorials, and we are going to start working with sensors. Now, what is a sensor? Sensor is something which allows an microcontroller or even us as humans or any animal to sense their surroundings. As humans have five sensors. We have our ears, nose, eyes, mouth, and our skin. And that allows us to perceive our environment, and it sends signals to our brains, and then our brain tells us what to do, and then we can use our actuators, which are our hands, arms, legs, our mouth, etc., to respond to the environment. So the sensors allow us to sense the environment. Now we're going to start with one of the basic sensors, which is the ultrasonic sensor. And what an ultrasonic sensor is it is not actually a sense which we as humans have, but there are other animals, and you might have guessed it correctly. A bat has an ultrasonic sensor. The way an ultrasonic sensor works is it sends sound waves, ultrasonic sound waves, towards the environment, and then it bounces back. It calculates the distance which it took for the sound waves to bounce back and come back, and that tells us how far or close something it is. So the closer you get to something, the waves will bounce faster. The further you are, the waves will bounce slower, which tells you how you are situated around in your environment. And let's see what equipment we need for it today. I'll switch my camera. All right, so as usual, we have our Arduino, and this is the breadboard. I have a smaller breadboard this time around, and we just need this ultrasonic sensor. I'll bring it closer to the camera. Let's see if I can get without adjusting it. All right, a little bit further. All right, so as you can see, it has 4 pins: VCC, trig, eco, and ground. VCC and ground are self-explanatory, which means one, VCC is where it receives the power supply. Trig is where it sends the sound waves out. So it will send the sound waves out from this side, for example. They will go out, they'll bounce back, and they will come here. And the time which it takes for the signals to come back, for the echo to travel back, is calculated based upon it determines its start time and then the end time, and then it is able to determine how much time it took, and that allows it to determine the distance. So how would we go about doing this? Let's go to our trusted chat GPT. So I just asked ChatGPT, hey, I want to connect an ultrasonic sensor to an Arduino Uno. Can you tell me the connections? The connections in this case are super simple. 4 pins. VCC goes to 5 volt, goes to ground. Trig goes to D9, and eco goes to digital pin 10. Now you can switch these around. They are not like super set in stone, especially only the trig and eco. These are set in stone, but these two you can use alternative pins. Not a big deal. So super simple. Now let me show you in Tinkercad how it looks like. So this is our ultrasonic sensor. This is an Arduino. 5 volts is connected to 5 volts on the VCC line over here, and ground is connected to ground. You can use any of these 2 pins. Some of the Arduinos might have multiple 5 volt pins, multiple ground pins. Either one of them is fine as long as the voltage parameters are met. 9 goes to trig and 10 goes to eco. And the code, we just come here, copy, and go to code. Now the good part about Tinkercad is something which I haven't shown you earlier, is you can do block coding. So you can always take blocks from here and just put in there, and it works. For now we are going to use text coding because we have the code, so not a huge thing. So we'll switch back to text, and I'll just paste it over here. Now this simulation, while it will say that it is working, it's not going to actually work. The reason is, how do you actually bring my hands? I can't bring my hands closer to what is a simulated thing. So we can see the result in the serial monitor over here, which says 113 centimeter. These are dummy values. It will only work when we do with an actual sensor, because we can't really bring anything close to it. But this is a good place to see whether your code is having any errors or not, and you can also visualize your wirings. Let's go to our thing, and let's start connecting this. So this is our ultrasonic sensor, and I'm going to take VCC, which is this wire. I'm going to connect it to 5 volts. Let's see, where is 5 volts? Is it done correctly? Yes, it is connected correctly. I'll connect the ground to ground. So this is this wire. It is going here, and trig goes to D9. I could have done this without the breadboard, to be honest. It's very simple, so we don't want to waste the breadboard. All right, that's pretty much it. Super simple. Let's check whether the wirings are correct. Trig is D9, echo is D10. Let's see. Trig is the blue wire is on D9, and yellow wire is on D10, which is echo. So the wirings look correct. I'll just make sure they're tight enough, and I'm gonna copy the code over. Just gonna copy this and paste it over here. Generally speaking, you should always save as whatever your new thing is. I'll call this ultrasonic sensor. It can't accept spaces, so you can use underscore. All right, now let's upload our code, and that's not working because my Arduino is not connected. Let's make sure that is connected. Rule number 1, always make sure that your wires are actually connected. And now it should work. So where will you see the results? You will see the results in something called as serial monitor. Let's see. See, the distance is now going to start showing up. I will try to adjust this on the screen so that you can see it properly. All right, so right now, see, if I bring it closer to the camera, the distance is reducing. If I put my hand on it, the distance is even less. If I remove it, the distance is more. If I point it away, the distance increases. So this is already signaling its environment. I'm pointing it towards me, actually the camera, roughly. Let's see what happens if I'm pointing it towards me. I'm about 50 centimeters away. So that's the distance. Let me point it somewhere else. Distance increases. Let's see if it responds to my hand. I'm going to bring my hand, I'm going to place it here, and I'm going to bring my hand closer. Closer. Very close. And I'm going to bring it farther. Close. Farther. So the ultrasonic sensor is working perfectly as we wanted it to, and it is giving us the distance. And what we can do with this, let's bring it back. See my pretty face? So what we can do with this is, now we have an ability to perceive what is around us, and we can use this to build a number of interesting things. For example, we can build an car which can go forward, and if it runs into an obstacle, it will pull back and turn around. Or you can build a following car where the car always wants to make sure that if you're in front of it, If you go further away, then it will try to maintain the distance so that it becomes a follower car. You can build a simple thing where you can have a passive buzzer where if you bring your hand close, it will start beeping. You can build something where you bring your light hand closer and the LED will blink faster. And the sky's limit. You can build a number of things. So just with like, and I'm going to, in our next video, I'm going to make sure that we try to combine this one basic sensor with our previous LED sketch and do something where if our hand gets closer, the LED blinks faster, and as the hand goes away further, then the LED blinks slower. And maybe we can also try to combine it with a buzzer where if the hand gets closer, then the buzzer's pitch goes up and it beeps faster, beep, 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 beep. And if it goes further, then beep, 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 beep. So uh, your imagination is really the limit in these things. You can use this in a large number of cases, but that's really the basics of robotics: a sensor, a microcontroller, and an actuator. Okay, you get these three things together, you can pretty much build whatever you want. Just like our human body, you have sensors, you have a brain, and you have actuators. You can do anything you want with just three major building blocks. So let's start working on them next time. Till then, bye bye.